Well, two events, A and B, are mutually exclusive. Probability of A is 0.3. The probability of B is 0.5. Work out the probability of A dash. A dash means not A. So what's the probability of A not happening? Well, if the probability of it happening is 0.3, then the probability of it not happening is 0.7, because we know that they have to add up to 1. Work out the probability of A or B. That U there means or. So work out the probability of A or B happening. Well, that's the probability of A, which is 0.3, plus the probability of B, which is 0.5. So that's 0.8. The probability of C is 0.4. The probability of D is 0.2. And we're told that the probability of C and D happening would be 0.06. Are they independent events? Well, if they were independent events, then we could find their probability of both of them happening by just multiplying them together. So the formula for that is the probability of C and D happening is the probability of C multiplied by the probability of D, if they are independent, as in if one event doesn't affect the other one. So the probability of C here is 0.4. The probability of D is 0.2. So the probability of C and D occurring, if they are independent events, would be 0.08, timesing those together. However, we can see that that's actually not the case. The probability of C and D happening is actually a little bit less than that. So that suggests that they are not independent events. The probability is actually a little bit less than that. So that's suggesting that if C happens, then the likelihood of D happening is actually going to be a little bit less than 0.2. Or if D happens, the probability of C happening is actually going to be a little bit less than 0.4. That's what that is suggesting. So they do affect each other. So they are not independent events. So basically, you just want to multiply the probabilities together. If we had got 0.06, then we would have said that they were independent, but obviously we didn't. So they're not.